Hi, I'm Bob. I hope the problems that we solved in the last video could help you better understand what is econometric analysis and what it could do. Today, we will complete the computer exercises at the end of Chapter 1, the nature of econometrics and economic data, in the textbook Introductory Econometrics, a modern approach, the 7th edition, by Professor Jeffrey Wooldridge. You can download all the datasets from the website below. I use Stata to do the computer exercises. Please check out my Introductory Stata 2022 course for details on using Stata. Let's look at the first computer exercise. Use the data in Wage 1 for this exercise. The first question is to find the average education level in the sample. What are the lowest and highest years of education? Here is the data. I write commands in the do file and execute the command one by one. To load the data, we type use, followed by the name of the dataset, wage1.dta. If the dataset is stored in a different folder, we should also type the folder's directory. Now we have the dataset. Let's look at the variables by typing describe. We can see the variables' names, variable labels, and other information. We find a variable called edu. It is the individual's years of education. If we type browse, we see the observations of all the variables. To find the average education level, we can use the summarize command. We see the mean, the maximum, and the minimum values of the variable. The average education level is 12.6 years of education. The lowest years of education is 0, and the highest years of education is 18. We could also use the command tabstat to find the same results. The second question is to find the average hourly wage in the sample. Does it seem high or low? We use the summarize command to obtain the average hourly wage in the sample. It is $5.9 per hour. It seems low. The third question. The wage data are reported in 1976 dollars. Using the internet or a printed source, find the Consumer Price Index (CPI) for the years 1976 and 2013. I found the CPI from the website of FRED, the Federal Reserve Economic Data. I typed annual CPI in US, FRED, into Google. And the first result is what I wanted. Click on it and I found the graph of the Consumer Price Index for all urban consumers. I could edit the graph and change the frequency to annual. Then I could download the Excel file of CPI data. Open the Excel file, and I found the CPI for 1976 is 56.9. The CPI for 2013 is 233. The fourth question. Use the CPI values from Part 3 to find the average hourly wage in 2013 dollars. Now, does the average hourly wage seem reasonable? In Stata, we use display to show the result of a math expression. We type display 5.9 divided by 56.9 times 233, execute it, and the result is 24.1 in 2013 dollars, which is reasonable. The fifth question asks how many women are in the sample, how many men. We found a variable named female. It is a dummy variable with two values, 0 and 1. It is equal to 1 if the person is female and 0 male. We use the command tabulate to show the frequency and percentage of each category. We type tabulate, followed by the name of the variable female, and we find 274 men and 252 women in the sample. Computer exercise number 2. Let's go to the second computer exercise. Use the data in BWGHT to answer this question. How many women are in the sample and how many report smoking during pregnancy? Using the command describe, we find 1,388 observations in the sample. The variable cigarettes reports the cigarettes smoked per day during pregnancy. When using the command summarize, we find that the minimum number of cigarettes is 0, meaning that not every woman smokes during pregnancy. The mean is 2.09 cigarettes per day. We can employ the command codebook, followed by the variable's name to have detailed information about the variable. We see the same mean and standard deviation of the variable as in the summarize. We also find the percentile of the variable. The 50 percentile, or the median, is 0. The 75 percentile is still 0. It suggests that the majority of women do not smoke during pregnancy. To know the exact number, we can try the command count if cigarettes is greater than 0. 212 out of the 1,388 women reported smoking during pregnancy. We can find the number of women who did not smoke by typing count if cigarettes is equal to 0. The second question, what is the average number of cigarettes smoked per day? In this case, is the average a good measure of the typical woman? Explain. We have already found the average number of cigarettes smoked per day, which is 2.09. It is not a good measure of the typical woman because the sample contains a lot of women who did not smoke during pregnancy. It makes more sense to say that the typical woman does not smoke during pregnancy because the median is 0. For the women who smoked during pregnancy, the average is 13.7 cigarettes per day. It can be seen using the command summarize cigarettes if cigarettes is greater than 0. The third question. Among women who smoked during pregnancy, what is the average number of cigarettes smoked daily? How does this compare with your answer from part 2 and why? We just got the answer. It is much higher than the average over the entire sample. The fourth question. Find the average of father's education in the sample. Why are only 1,192 observations used to compute this average? We employ the stata command, summarize, followed by the variable's name. The average of father's education is 13.2 years of education. There were 1,192 observations for this variable because some of the father's education attainments are missing. We can use the command codebook to find how many observations are missing. There were 196 observations with a missing value on the father's education. Those observations are excluded in computing the average of father's education level. The fifth question. Report the average family income and its standard deviation in dollars. Using the command summarize again, we find the average family income is 29.027 and its standard deviation is 18.739. Since the unit is $1,000, the average family income is $29,027 and its standard deviation is $18,739. Now let's go to the third computer exercise. The data in MEAP01 are for the state of Michigan in the year 2001. Use this data to answer the following questions. Part 1 asks us to find the largest and smallest values of mass 4. Does the range make sense? Explain. Using the command summarize, we find the largest value of mass 4 is 100% and the smallest value is 0. It makes sense because it measures student satisfaction. The range of satisfaction is between 0 and 100%. Part 2. How many schools have a perfect pass rate on math tests? What percentage is this of the total sample? I could not find the perfect pass rate on the math test in the sample. If we define it is a perfect pass if the student's satisfactory measure is above 90, then 333 schools have a perfect pass rate, which is 18.3% of the total sample. Part 3 asks how many schools have math pass rates of exactly 50%. We continue to use math 4 to measure the pass rate, and 17 schools have math pass rates of exactly 50%. Part 4 asks us to compare the average pass rates for the math and reading scores. Which test is harder to pass? We summarize the two variables, math 4 and read 4. We find that the mean for math is 71.9 and the mean for reading is 60.1. It implies that reading test is harder than math. Part 5 asks us to find the correlation between math 4 and read 4. What do you conclude? We type the command correlate, followed by the two variables. The correlation between them is 0.84. The two pass rates are highly correlated, suggesting that those schools with a high pass rate on math also have a high pass rate on the reading test. Part 6. The variable EXPPP is expenditure per pupil. Find the average of it along with its standard deviation. Would you say there is wide variation in per pupil spending? The average expenditure per pupil is $5,195. Its standard deviation is $1,092. There is a wide variation in per pupil spending. The range between the minimum and the maximum expenditures is also large. Part 7. Suppose School A spends $6,000 per student and School B spends $5,500 per student. By what percentage does School A spending exceed School B's? Compare this to the formula 100 times log 6,000 minus log 5,500, which is the approximation percentage difference based on the difference in the natural logs. The difference between the spending is $500. The percentage of the difference is 500 divided by the average of the two school spending, 5,750. The result is 8.7%. When we use the approximation based on the difference in the natural logs, we get a similar number. Let's complete the fourth computer exercise. The data in JTRAIN2 come from a job training experiment conducted for low-income men during 1976 to 1977. The first question asks us to use the indicator variable chain to determine the fraction of men receiving job training. We can first take a look at the variables using the command describe. The binary or dummy variable chain indicates whether the worker is assigned to a job training. Using the command tabulate, we find that the fraction of men receiving job training is 0.4157. The second question, the variable RE78 is earnings from 1978, measured in thousands of $1982. Find the average of it for the sample of men receiving job training and the sample not receiving job training. Is the difference economically large? We type summarize, followed by rule 78 and the if modifier. For the workers receiving job training, their average earnings are $6,349. For the workers without job training, their average earnings are $4,555. The difference is $1,794. It is economically large. On average, the workers receiving the job training earned $1,794 more, or 33% more than those not receiving training. The third question, the variable unim78 is an indicator of whether a man is unemployed or not in 1978. What fraction of the men who received job training are unemployed? What about men who did not receive job training? Comment on the difference. We use the command tabulate with the if modifier. Since we want to see the fraction of unemployment, we type tabulate unim78 followed by if chain is equal to 1. We see that 24.32% of men who received job training are unemployed. By contrast, the fraction of the unemployed men who did not receive job training is 35.38%. The percentage of unemployment is higher for the men who did not receive job training, which is evidence that job training can improve workers' employment. The fourth question, from Part 2 and Part 3, does it appear that the job training program was effective? What would make our conclusions more convincing? From Part 2 and Part 3, we know that the men who receive job training earn more and are more likely to be employed. To make our conclusions more convincing, we can develop an econometric model and include more control variables in the model, such as age, gender, race, marital status, and educational attainment. In this way, we can rule out the effects of these control variables on the outcome. For example, we can regress log earnings on the indicator variable chain and some control variables, age, education, black, and married. We find that the estimated coefficient for job training is 0.024. It suggests that, on average, the workers who receive job training earn 24% more than those who did not, holding other relevant factors constant. The effect is significantly different from 0 at the 5% level. Computer exercise 5. Here's the fifth computer exercise. The data in Fertile 2 were collected on women living in the Republic Botswana in 1988. The variable children refers to the number of living children. The variable electric is a binary indicator equal to 1 if the woman's house has electricity and 0 if not. Find the smallest and the largest values of children in the sample. What is the average of children? Using the command summarize followed by the variable children, we find the smallest value of children is 0 and the largest value is 13. The average is 2.27. The second question, what percentage of women have electricity in the home? We apply the command tabulate to the binary variable electric. 14.02% of women have electricity in the home. The third question, compute the average of children for those without electricity and do the same for those with electricity. Again, we use summarize with the if modifier. We type summarize children if electricity is equal to 1. For the women with electricity, the average of children is 1.90. The number is 2.33 for women without electricity. We find that the women without electricity have more children than those with electricity on average. The fourth question is, from part 3, can you infer that having electricity causes women to have fewer children? Explain. The correlation between the number of children and electricity does not necessarily show a causal relationship. There are many other factors that affect fertility, such as educational attainment, age, race, and family income. These factors are also correlated to access to electricity. Without controlling for these variables, we could not conclude that electricity is the cause of a lower number of children. For example, a woman with a higher family income is more likely to have electricity in her home than a poor woman. If the wealthy woman tends to have fewer children, then the lower number of children is due to family income rather than electricity. Computer exercise number 6. Use the data in county murders to answer this question. Use only the year 1996. The variable murders is the number of murders reported in the county. The variable X is the number of executions that took place of people sentenced to death in the given county. Most states in the United States have the death penalty, but several do not. The first question is, how many counties are there in the dataset? Of these, how many have 0 murders? What percentage of counties have 0 executions? We describe the data and find the variables county ID and year. If we order the variables, sort them, and browse the data, we can see the observations for the county with ID 1001 from 1980 to 1996, and then another county with ID 1003 from 1980 to 1996. It is a panel dataset. We only use the 1996 data in this computer exercise, so we keep the 1996 observations and drop the others. Using the summarize command, we find 2,197 counties in the sample. The variable murders reports the number of murders. We could find the numbers of counties with 0 murders by typing count if murders is equal to 0. There were 1,051 such counties. The variable x6 reports the number of executions. We find 2,166 counties with 0 executions. The percentage is 2,166 divided by 2,197, which is 98.6%. The second question is, what is the largest number of murders? What is the largest number of executions? Compute the average number of executions and explain why it is so small. We use the command summarize to obtain the maximum number of murders and executions. They are 1,403 and 3, respectively. The average number of executions is 0.016. It is so small because less than 2% of counties have executions. The third question is to compute the correlation coefficient between murders and executions and describe what you find. Using the command correlate, we find the correlation coefficient between murders and executions is 0.21. The coefficient is positive, which makes sense, but it is small because most counties have no executions. Here is the fourth question. you should have computed a positive correlation in Part 3. Do you think that more executions cause more murders to occur? What might explain the positive correlation? The positive correlation does not necessarily mean causality. First, we should figure out the direction of the causal relationship. It makes more sense to say more murders lead to more executions. Second, we should consider other factors that affect both murders and executions. Such factors could be the population of the county and its economic growth. For example, a county with a high population is more likely to have more murders and more executions. So the positive correlation may be due to the population. Let's go to computer exercise number 7. The dataset in alcohol contains information on a sample of men in the United States. Two key variables are self-reported employment status and alcohol abuse. The variables employed and abuse are both binary or indicator variables. They take on only the values 0 and 1. The first question is, what percentage of the men in the sample report abusing alcohol? What is the employment rate? We use the command tabulate followed by the binary variable abuse. We find that 9.92% of men report abusing alcohol in the sample. Tabulate the variable employ. The employment rate is 89.82% for the entire sample. The second question is to consider the group of men who abuse alcohol. What is the employment rate? We type tabulate employ if abuse is equal to 1. The employment rate is 87.27% for men who abuse alcohol. The third question is to compute the employment rate for the group of men who do not abuse alcohol. It is 90.10%, higher than that for the men who abuse alcohol. The fourth question discusses the difference in your answers to Part 2 and 3. Does this allow you to conclude that alcohol abuse causes unemployment? The correlation between them does not necessarily mean causality. First, there could be a reverse causality here. On the one hand, people who abuse alcohol are less likely to find jobs. On the other hand, unemployed people are also more likely to become addicted to alcohol. We should separate the effect of one direction from the opposite direction. Second, many other factors could affect employment and alcohol abuse, such as marital status and family background. Without considering these factors will lead to omitted variable bias. Finally, we reach the last computer exercise. The data in Econometrics were obtained on students from a large university's course in Introductory Microeconomics. For this problem, we are interested in two variables, score, which is the final course score, and econ HS, which is a binary variable indicating whether a student took an economic course in high school. The first question, how many students are in the sample? How many students report taking an economics course in high school? We type describe and see 856 students in the sample. Among them, 317 students report taking an economics course in high school. The second question: find the average of score for those students who did take a high school economics class. How does it compare with the average of score for those who did not? The average score for the students who took a high school economic class is 72.08. The average score for the students who did not is 72.91. The latter is a little bit higher. The third question: do the findings in Part 2 necessarily tell you anything about the causal effect of taking high school economics on college course performance? Explain. No, the findings do not tell me the causal effect of taking high school economics on college course performance because many other factors could affect the student's college course performance and whether she took an economics class in high school. If they are omitted from the model, it will lead to bias. And if we run a regression, we will find that the coefficient is not significantly different from 0. So there's no significant relationship between them. Thank you so much for doing the exercises with me. I hope the solutions can help. See you. Thank you for watching this video and subscribing to my YouTube channel. See you next time.